Good day everyone. We are from section 2 Bmmm S1/1 here to present about the group project which is force and factor of safety analysis from actual structure. These are my group members. My name is Sri Vishnu Jaisilan. My metric number is B0920104006. For introduction, force is the push or pull on an object with mass that causes it to change its velocity. Force is an external agent capable of changing the state of rest or motion of a particular body. It has a magnitude and a direction. Factor of safety is the ratio of the ultimate strength of a member or piece of material to the actual working stress or the maximum permissible stress when it's used. For the objectives of this project, we need to study the force and factor of safety analysis from actual structure, and to draw FBD from actual structure, to develop the equilibrium from the equation of equilibrium for the forces act on the structure, and to determine the factor of safety used in the structure. Thank you.
Hello, my name is Surendran Balakrishnan. My metric number is B0920100384. I am from section BMMM S1/1. The course I am going to present is BMMM 2303 for the solid mechanics. Justification of structure selection. The topic I am going to present is those. There were many types of structure for the bridge. Example like steel truss bridges, modern bridges, wood steel truss bridges, suspension bridges, and also more. Geometry type of trusses. We select steel truss bridge as our structure. As a justification, the steel trusses took advantage of the axial stress capacity of the bar element, creating bridges with longer spans, low weight, and enough stiffness to withstand higher loads due to the large number of geometries that can be created with trusses. There are possible arrangements with the bar elements taking advantage of the tension and compression stress capacities. With the structural steel available on construction market, these bridges had a significant improvement, including the increase of spans, length, cover, and supporting higher loads. Steel trusses bridges replaced wooden trusses and began to build a bigger structure and also kind of strong structure. There are the geometry type of trusses. Example like Pratt, Warren, Baltimore. Loading and mechanical response. Okay, there are four types of forces. Each member of a bridge is intended to respond to loads in a particular way. The bridge's inspector must understand the manner in which loads are applied to each member in order to evaluate if the function size. Indeed, there are four types of forces. The first force is axial force, compression and tension. Axial force is a push or pull type of force which acts parallel to the longitudinal axis of a member. An axial force causes compression if it is pushing and tension if it is pulling. The picture shows the process. And the second is bending stress. More to flexor, bending stress flexor. Bending forces in bridge members are caused when a load is applied perpendicular to the longitudinal or neutral axis. A moment is commonly developed by the perpendicular loadings which cause a member to bend. And the third is shear force. Shear force is a which result from equal but opposite transverse forces which tend to slide one section of a member past an adjacent section. The picture shows the process. As the support on the left bottom and the load is upper and the neutral axis come from right. So the fourth is torsional force. Torsional is a force resulting from an externally applied moment which tend to rotate or twist the member about its longitudinal axis. The picture shows the process. The first picture shows how it twists when the torsion, and the second is torsional distortion. That's all from me. Thank you.
Hello and Assalamualaikum. My name is Hikmal Hakimi bin Badrul Hisham. I'm from class BMMM section 1/1. My metric number is B0920100062. Okay, today I will explain the calculation that I have made for this assignment. As we know, the structure that we have chosen is a bridge. So this is the FBD of the bridge. Okay, as we can see, the bridge have too many unknowns. So after discuss and getting advice from our lecturer, we only need to calculate the beam only at point C to point D. So we have only four unknown, which is Cx, Cy, Dx, dy, and got one force, which is 20 kilonewton. This is the FBD of point C to point D. Okay, first we calculate the equation of the equilibrium. Okay, Fa equal to 0, to the right positive, negative Cx plus Dx equal to 0, Dx is equal to Cx. Okay, next force Y equal to 0, upside positive, negative Y minus 20 kilonewton minus dy. So Cy plus dy equal to negative 20 kilonewton. Okay, we must calculate the moment to solve this equation. Okay, moment we choose at point C equal to 0, clockwise positive, 20 kilonewton times 10 plus dy times 20 equal to 0, dy equal to negative 10 kilonewton. So we insert the value in Cy plus dy equal to negative 20 kilonewton. So Cy minus 10 kilonewton minus equal to minus 20 kilonewton. Cy equal to negative 10 kilonewton. Okay, next for the shear force and bending moment. First we find V1, uh, Fy upside positive, 10 kilonewton minus V1 equal to 0. V1 equal to 10 kilonewton. For the moment at C, anti-clockwise positive, negative 10 kilonewton times 0 plus m1. We times 0 because there is no distance at point C, so m1 equal to 0. For V2, Fy equal to 0, upside positive, 10 kilonewton minus 20 kilonewton minus V2 equal to 0, V2 equal to negative 10 kilonewton. Okay, for the moment at W, anti-clockwise positive, negative 10 kilonewton times 10 kilonewton plus M2 equal to 0, M2 equal to 100 kilonewton meter. For moment at D, we know that it will be 0, so moment D equal to 0. Okay, this is the shear force diagram. We start at 10 kilonewton positive and 20 kilonewton negative. So it going down and 10 kilonewton positive, it going up. Okay, next for the bending moment diagram, the uh, bending force is positive, so the graph is positive. Okay, for the factor of safety, the material that we choose for this beam is concrete. The ultimate strength of the concrete is 70 megapascal. For this factor of safety, uh, formula is strength over stress. So we need to find the ultimate strength and the stress. We already find the ultimate stress, which is 70 megapascal. So to find the bending stress, the formula is mc over I. M we already get from the calculation earlier, which is 100 kilo Newton meter. C is the C is kosong sorry C is 0.25 meter, and I 2 meter times 0.5 meter, power of 3 over 12. We get 0.0208 meter 4 meter 4. Okay, so the bending stress we get 1200 kPa. We convert it to megapascal, which is 1.2 megapascal. So the factor of safety is 70 MPa over 1.2 MPa equal to 58.33. Okay, that's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Muhammad Qayyum bin Suhaimi. My metric number B0920101439. So today I would like to do a conclusion, which is from our assignment, we get to know the vertical loads, magnitude and their location on the truss. Furthermore, the bridge is support only at the bottom end nodes, and the bridge and every node is at equilibrium. Also, we can analyze the moment this load produce respect the bottom end to determine direction there, and then the node so analysis force using FBD to obtain the corresponding pair of equilibrium equation. Lastly, we can solve the obtained system of equation using the substitution method. Okay, that's all from me. Thank you.